About radio.
Hi guys, yesterday I set out to make a video and the title of it was going to be checking the IF alignment of the Eddystone communications receiver, and I got everything set up and went through all of the things that I was going to do, and if you've seen the earlier videos you've seen the wobulator, and I got the wobulator set up, but I couldn't find the any trace of that characteristic bell that you see when you inject the signal into the IF transformers and then look at the resulting signal that you get after the detection of that signal. It was a completely flat response. I couldn't find it at all, and I thought, well, what do I do now, because it was a real problem. Anyway, before I got very far, my old scope, the tele-equipment scope, gave up, and there's a very distinctive smell coming out of it, so there'll probably be another video of how to try and mend the oscilloscope. So because I got started, I thought, well, I'm going to carry on, so I've actually pulled the alignment into place with the aid of a meter and signal generators, and I'll show you what I've got, the remnants of the video that I started to produce yesterday. So I think it's the plans of mice and men. You know, I had this grand idea of a wonderful video showing you this, and it all went belly up. I'll either put an X output on this oscilloscope so as I can drive the wobulator from my other oscilloscope, or I'll have a look at mending the tele-equipment scope. But at the moment, I say this is just going to be the ramblings of a radio enthusiast, because that's about it. It'll probably take me 2 videos to cover what I want to cover, so thanks for your forbearance, and I hope you enjoy it. Hi guys, what I'm going to do today is run through the IF transformer alignment in my Eddystone communications receiver. It's likely to take me some time. I would like to have made it all in one video, but you know, I waffle on a bit too much at times, so it's likely to run over into 2 or more videos, so I hope you find it worth while hanging on. But the reason for that is I want to make it as detailed as I can, because I only want to do this once, but I would like to share with you what I'm doing. I'm not an expert in this at all, but I will show you what I'm doing. So this is about what I'm doing rather than the expert professional way that it should be done. So you may find other sites that give you better information or more information. This is simply what I'm doing. So this is as you understand it, and I'll show it to you warts and all, so if I do something and get it wrong, I'll show you what it is that I've got wrong, in the hope that you don't make the same silly mistakes as I may make. Not that I'm planning to make any, but they say the guy that never made a mistake never made anything, and I've made a lot of mistakes. Okay, so I hope you enjoy it. And thanks for looking in. This is the radio from Eddystone, and I'll go through the controls. What have the audio frequency, I'm going to set that just partially turned, just so as when it wakes up we'll hear a bit of something. The selectivity here we want at maximum. I'm trying not to get in the shot. and I'll talk to you a bit more about that, as it frightened me when I first bought this radio. AVC we want off, and the noise limiting we want off. Crystal phasing we want off. The tuning we don't care, so we'll leave that in the middle. The range change switch we want on position 1. The beat frequency oscillator we turn off, so it doesn't matter where that is. The RF gain we want at maximum, and this send switch we want on, and when we get to around to it, we shall want the mains to be on as well. In an ordinary domestic radio there would be 2 intermediate frequency transformers typically, and in a communications receiver like this we've got 3 transformers. So this is the first, second and the third transformer. And I said about this selectivity switch, I'll give you a close-up in a minute, but when I first got this radio, the selectivity switch was in the next position, so in a sort of not between maximum and minimum, and what happens is the switch mechanism at the front operates a wafer switch, but it also operates a series of arms which changes the position of the primary and secondary cores, so they actually move closer or further apart, moving further apart as the selectivity increases. So only those stations that are truly coupled will get through, and then as you move towards minimum selectivity, the transformers get very close together and coupling becomes much easier, and you'll get much wider spread of stations being received. But I thought, it's been dropped and the IF transformer has moved, but I'll get you some close-ups of that. Out of interest, while I'm here, what they've done is, I say this is first, second and third IF transformer, and that's the primary and the secondary, and then on this one that's the primary and secondary, and again here it's primary and secondary. So when I actually come to go through the procedure and I'm talking about which core I'm adjusting, I shall call that number 1, number 2, number 3, number 4, number 5, number 6. So I'll try and make sure I remember to identify that, but just when I talk about going through the cores that I'm adjusting, that's the order I'll be doing them in. So this is the selectivity switch. It's quite stiff and it's on maximum at the minute, and then it's got 4 positions, and I'll pop it back to maximum and I'll show you what it does to the transformer. I've got the selector switch in the maximum position, and you see these bottom cores are all in line with the holes. These top cores are permanently in those positions, but I'm going to slowly move the switch into the next position, and you see what happens to those transformers. I'll bring them back down. You see how they're disappearing, they're getting closer to there, and with each subsequent switch position, so they move closer. You see that's 4 positions there. So this is looking under the radio, and here there are 3 cams and the 3 arms, and as I move those, that's back in the maximum position. So these rods, these little connecting rods, move the IF transformer. I've never seen inside these particular IF transformers. I'd like to have had a look, but to get the cans covers off, you've really got to disassemble the whole thing. It looks as though they are the covers were put on and as a finished assembly, and then the finished assembly bolted into place, so not easy to actually get inside there, and not just for a look anyway. This is the circuit diagram that I got with the radio, and it's on 2 bits of A4, I suppose one A3 page. But what I've done is I've totally redrawn that, and you can get a copy of this from the Eddystone user group site. I'll give you a link. But what I've done is I've broken up the circuit into several sections so that each one can be printed on an A4 page, and then the two go together rather nicely. You don't lose any detail. You know what it's like when you join 2 maps together, and the bit you want's always on the crease. So hopefully that'll help you if you've got one of these, or if you just want to follow along. So I say that's over 4 pages. Why am I showing you this? The IF transformers, so it's 1, 2 and 3, so first, second and third. I produced this article on the wave change switch because the manufacturer's information wasn't very clear, but hopefully you'll find this useful. The equipment I'm going to be using for this test is the stuff you've seen before in other videos, but that's the advanced signal generator, and that's going to be running at 450 kilohertz. It's just teetering between 450 and 449.999 kilohertz on the frequency counter there. I'm going to be modulating this with this signal generator, the level decade oscillator, and we'll be modulating this 450 kilohertz at a depth of 30% or thereabouts. I'll be using this old Telequipment oscilloscope, because that works with this wobulator, and again the wobulator you've seen in other videos, but I will go through that when I start to set it up. So what I'm setting out to do is check the alignment. I'll only start adjusting things if I feel it needs adjusting it. Having said that, I probably won't be able to resist giving it a twiddle and seeing if it's adjusted correctly. Okay, so that's the equipment. The manufacturers have identified the injection point here as point X in the manual there, and I'll just identify that in the radio. I have the front of the radio towards the front of the bench there, and the point that I want to get to is this coil here, and we are the terminal that's at the 9 o'clock position. So the little probe that I have got to connect on there won't actually isn't very comfortable and is likely to drop off. So what I'm going to do is just put a crocodile clip on there, and then I'll couple this little probe onto that crocodile clip, and the other probe, this is from the wobulator, the other probe of course is going to go to the chassis somewhere. I'm actually working on a pair of step ladders to get up high enough to be able to see the back of the camera and get my focal distances something like right. But anyway, that's what we're going to have there, guys. So that's my 450 kilohertz, and that's the 30% modulation or thereabouts, and that modulation is at 400 hertz, and that's how you work out the modulation depth if you're interested. I'm going to cut here, and we'll go to the next video, but I haven't got to the disaster yet, but I'm getting there. Thanks for watching, guys.